Please welcome founder, chairman, and CTO Rethink Robotics, Rodney Brooks.
Thank you. I'm very pleased to be here, honored to be here. I was a professor at MIT for a long, long time. So I'm going to talk today about robots in the future and robots and how they may interact in jobs. To help me, I've got Matt Ryan here from Rethink Robotics. He's the lead software person who developed a lot of what we're going to see today. And if we could have the screen up above of inside Sawyer's brain. We've got a laptop here looking inside the brain of this robot, Sawyer. And Sawyer is a robot we're deploying across the world into factories in countries in Europe, Asia, North America. And Sawyer has vision and force sensing and is meant to be used by ordinary factory workers. I'm going to come back to that in a minute because it's important. First, if we can look down here, Michael, and bring Michael up on the screen. I'm just going to reorient this, this set of parts here, and you see that little fiducial marker down there. If we go back to the screen now, we'll see up on the screen, we'll see the camera view. It's finding out where that fiducial is, and now it knows where, and we can go back to Michael's camera, now it knows where the orientation of those parts are. Because in factories where people are, things come randomly oriented, and so we need the robot to be able to adapt to the messiness of humans. In this case, we've got a particular set of little patterns there, but in real life, the plastic tray that may have the parts in it will have writing on it, so it gets the writing orientation and now can operate. And Michael, if you could step back, I just want to come in close. And an important thing about a robot like this, it's meant to have people interact with it, is that it should be safe to be around and not kill you. If you try that with a conventional industrial robot, things are not going to end well. Trust me. I'm okay. So, thanks. So this robot is doing its task. You can see a representation of its internal task up there, and the green little marker is moving around, showing where it is inside its brain, what it's thinking about. And that's a fairly sophisticated sort of representation that you can go down and drill down and control things. But Matt, can you stop the robot and set up for another task? But we also want our robots to be used by regular factory workers. I think that's an important thing, that if we make technology and we leave out ordinary people, it's going to be very bad for them in the long run. Now, I guess a few of you probably have things like this, right? And who had to go and take a course on how to use it? None of you. Why is that? Because the people who designed this, who want to sell lots of them to you, made it so the phone teaches you how to use it. And I think our technology for advanced manufacturing, other sorts of jobs, should be training the workers as they use them and lead them into it. So we're going to have an example here, and if we can now go to the screen before you start, Matt. So if Michael's looking at the head of the robot, this time Matt is not going to have to look inside the robot's brain with his laptop. Matt is a factory worker, and all he knows how to do is grab the robot and show it a task. So he's going to grab the robot, press a button on it, it's going to close the fingers. As it closes the fingers, it realizes that he wants to do a pickup, and it builds that tree of instructions. So he's automatically programming the robot without having to think about it. Now he's going to show it this grid here, because he's going to put the pieces in the grid. And when he clicks the button, it says up on the screen, how do you want to arrange this? He says, I want a pattern. And now he's going to show the four corners of the pattern as he goes around and shows the pattern it's going to do. He's just grabbing the arm. It's trying to apply zero force to him. It's filling in the pattern in the screen. Once he's got the four corners there, it will have built a very complex tree, which we'll see in a minute. But he doesn't have to worry about that. All he knows is that it's asked him to tell how many rows, how many columns, and it's got a 3 by 5 array, and now he's finished programming a simple task. He didn't have to do any coding. He didn't have to understand anything deep. He just had to have a few ways of interacting with the robot, and it's now able to do this task. So he says run, and off it's going to go, and starts off slowly because he may be nearby. Then it's going to start picking up these pieces and put them into the tray. I don't have the time showing for me, so I can't tell how long I've got to go. If you could put that up, that would be great. So now it's doing this simple repetitive task. So Matt, could you stop that, and let's show one other thing. We had vision. Professor Reif?
He's not here.
He's not here? Oh, he's here. I see Professor Reif. Come on up. So, come on over here. It's safe. It's safe. This is a force sensing technology which was invented at MIT and which we licensed from MIT. I heard it was safe. So, Raphael, if you just lift here, push that up and push that up. It's applying 20 newtons. Is it 20 newtons? 20 newtons. So just move it up and down, and you can feel that force, right? Now, Matt, can you go stop that? And now if we put up on the screen for a second the inside of the robot's brain, Matt is going to go and edit from, was it 15 or 5? He's going to edit to 50 newtons and run it again. And this is just to show that MIT's technology is able to measure forces accurately. So now try it. It's harder, right? Is it harder?
No.
Oh. You know, I chose Professor Reif because he's the most honest man at MIT.
It was hard.
It was harder. So we can control the forces exquisitely, even though that was the vertical forces, had to measure all the forces on all the joints, use Jacobian, et cetera, to get the forces. But we can measure forces, so we can apply forces in doing assembly operations, which is what people in very repetitive tasks quickly apply forces. And this is a key thing for both measuring safety and for being able to control manufacturing processes.
Am I too close?
No, you can get closer if you want, but I thank you for your help. And I thank MIT. So thanks Michael, and thanks Matt. I just want to finish up and talk a little more about robots and jobs, because it's a thing that's in the press that people are afraid robots are going to take away jobs from everyone. But in fact, in manufacturing, we have a labor shortage in the US in manufacturing and repetitive tasks. People are not willing to do those jobs anymore. In China, we have a shortage of labor, and the large supply of low-cost labor has disappeared largely in China. In Japan, it's already happening. But we're starting to see labor shortages in other areas. The average farmer in Japan is age 67 years old. In the United States, it's 58 years old. We are going to have a shortage of lots of physical labor, and I think we're going to need more and more robots to help us make up that labor shortage. But more importantly, I see for the next 20 or 30 years a real change in our society in North America, in Asia, and in Europe, brought about by a demographic inversion. We are getting to be an older society. Baby boomers like me are about to get quite old, and there are less younger people. In Japan, the ratio of working-age people to elderly people, 65 and over, is changing from 9-to-1 to 2-to-1. It's not quite as extreme in the US, but the more we inhibit immigration in the US, the worse the ratio gets here too. So we're going to have a lot of older people with less younger people to do the hard physical labor or to be involved in elder care and help people maintain their independence and dignity and stay in their homes longer. So over the next 20 to 30 years, we're going to see robots like that, not just for manufacturing, but which are easy to interact with, which can apply forces, measure forces, are soft enough to interact with and have people close to, are going to become more important in many aspects of our lives. One way of viewing this is robots are going to take away all the jobs. and we're not seeing productivity gains. But I think it's actually a much more complex problem that we're facing. There's many, many different flows happening all at once. There's the demographics of aging demographics, the demographic inversion happening. There's urbanization happening, which is why old towns in the US where there used to be small towns out in the Midwest states where there used to be plentiful labor, there's no labor now because the young people leave. We see rising educational attainments. People don't necessarily want to work in factories or work in elder care, helping people physically. We see through the internet aspirations of everyone wanting better jobs. And lastly, we see a sort of culture in Wall Street of shareholder value, which tries to place returns to shareholders over longer-term high wages to employ good people, and very much a short-term sort of approach. So I think all these currents come together, and it's not simply robots taking jobs. There's reasons we need more robots to help with jobs, but I think we also have to be clear on how we're going to bring along workers with the robots by having the robots be able to interact with the workers and have the workers use them as tools, not as some sort of device that they can't be part of and be part of the gains of productivity of. Thank you for your time.